Okay, hello. Let's start our 7th lecture. And today we will talk more in depth about Node.js environment, and actually we will set up a working Webpack configuration so you can build your front-end assets on your own PC without using any external tools like codepend.io. What we did yesterday, we talked about HTTP protocol. It's a set of rules which browsers and servers use to talk to each other. And the main part of HTTP is the message that is sent via HTTP is defined by some stuff that is put in this message. And this stuff includes the keyword for method that is used for this particular request, the URL which request goes to, the additional data that is included with the request. For example, as you can see here, we may push additional data via query parameters for the query, like this. So if on the server we have the only one handler for this path, it can get some parameters. For example, if it would be like website.com/multiply, via query params, we could provide something like a equals 5 and b equals 3, and expect this endpoint to return us 15. But another way to send the data, if we are sending not get params, but for example, not get requests, but for example, post requests or put requests, is to provide data actually in the body of the request. And this is better than sending data in the URL parameters, because this data may be arbitrarily large, while for the query parameters you have a limitation for something around like 256 or 1000 symbols. And this body data is just a textual string, and maybe in any format, and we decided to use JSON because it's a common choice for now. And also we talked a little bit about cookies and HTTP statuses. Basically, when server returns the response, with that response there is a status attached, and browser, by looking at the status may see if request was completed good or not. So the 200 response status means that everything is okay. And for example, you may go on some web page and see 404 response status, which means that a resource is not found. And I showed you how to check the status. And also on the websites, you may see that actually websites, if server cannot, for example, find the page, they show their own custom 404 page. For example, if I go to the GitHub, github.com, and try to open some repository which does not exist, for example, github.com/Facebook/ I don't know, Chrome, maybe, it displays a custom-made 404 page, which is returned by the server, but with this page, actually a status code is returned, and we can see this status code in the network tab in developer tools. If I update it, you can see here our first request, which was made to this page, returned with status 404. So browser knows that this file wasn't found. So it's useful for adding additional metadata with your response. And the cookies is basically a third way to send data with your requests, but cookies are preserved between different requests. So basically, cookies may be saved only once, and then they will be sent with each request to the same server. You do not have to specify the values again. And when browser loads any file or any URL, what it basically does, it sends an HTTP request and waits for some response. And then I showed you how to make these HTTP requests from your own JavaScript code. For this, we can use either native, or I should say default vanilla way, using XML HTTP request class, or a little bit simpler way with using jQuery function, jQuery.ajax. And as you can see here, with this function, you can pass some of the parameters we discussed before, like method, or data, or URL. And after this request is completed, two of these three functions is called. So after request completes, you either see success if the return status was 200, if everything went okay, and if there was an error, for example, if file is not found or URL is not found, this error function will be called. And after both of them, the complete function will be called. So you can write this code in your browser and send requests by yourself. Okay, and then we spent a lot of time talking about asynchronicity in JavaScript. Basically, this means that code may be executed in a different way than you specified in your code. Yeah. So, for example, here I save the time when this line was executed by just creating a special JavaScript date object. It simply holds the current time. Then I create a timeout, and this timeout, to this timeout, I pass a function that will get the new time and calculate the difference between the new time and the saved old time, and save it in a variable delta, and then log this variable. And I say that this function should be executed after 2 seconds or 2,000 milliseconds. And if I do not write the last line of code, this function will be executed only after 2 seconds, and the message will be logged as we saw yesterday. And if I call this function, I actually disable this timeout, so it will be never executed. So this way you can save up some functions for later execution, and also you can do basically quite the same asynchronous stuff when you sending HTTP requests, like on previous slide. Basically, success, error, and complete are functions saved for later execution. And the other place where we were writing asynchronous code is subscribing to the events. So when you subscribe to the events, subscribe to some event, you provide a function that should be called only when that event happens, not now. So this is also save this function to be executed later, in a later time. And then I showed you some HTTP APIs developed by other people. API stands for Application Programming Interface, and this abbreviation is used everywhere in programming. But for HTTP APIs, it's generally some website that provides you some data. Not web pages, but the data in the common data format, for example, in JSON. And there may be something like a JSON HTTP API, and you know that this API sends you data back in JSON format. And I showed you two APIs, for example, Star Wars API and Fixer.io, that allows you to get some data, for example, to get currency exchange rates. And I also showed you the third API called myjson.com. With this, we actually changed some data, not only get some data, but also pushed some data to this API, and it was saved. And there are more complex APIs, for example, Facebook API or Google API or Contact API, but they require you to actually register your application on their service. You cannot use them just from out of nowhere, you have to register. They will provide you a special key, and you should use this key to send the request to the server. And then, for example, Google can calculate how many requests you sent and say you that you're sending too much requests and ask you for payment, for example. And if API requires you to work with users, for example, like Contact API, with Contact API, you basically can do everything a user can do on Contact website. But to do this, not only you have to register your application on the Contact website, you should also allow users users should also allow your application to access its own data via Contact interface. So it basically you will have two keys. First key will be for your application, and the second key would be for this particular user. And only then, after this complex process, you will be able to behave like a user on Contact. But we haven't discussed this in deep, only like on the ground, on the surface. And I showed you how to use a special tool called Postman to debug other people's APIs or your own API before actually writing a code. So we used Postman to send the requests to other APIs, and today we will use Postman to send requests to our own APIs that we will write. And I also showed you the promise, which is a special JavaScript pattern for asynchronous code execution. What it does, it's like changes the way you may think about asynchronous code by wrapping some asynchronous function in a promise object like this. What happens when we create a new promise object? We provide a function to it, and this function will be immediately executed. But this function only does one thing. It schedules the timeout for later execution. So function saves this code and returns back. And then we can say that after the promise was completed, we should call some another function. And after 2 seconds will pass, actually, since we can call here resolve function, and it will pass this data we provide to the resolve into this success callback we provide in them. So this way we can chain some asynchronous code and execute it one by one, for example. Make requests one by one. And I showed you that you can use promises for either consequent code execution or parallel code execution. Basically, you're just chaining the then callbacks. And with parallel code execution, you can easily use the special function called promise.all that will wait until all previous promises are finished. So this way you can, for example, send 10 requests and easily wait when each one of them is completed, and use all the data from all the 10 requests. I later told you about jQuery promises, but actually, since we will be using Webpack, you do not have to think about jQuery promises, because Babel will provide us with the native promises, and that's good. But the cool thing about jQuery is that it provides the promise-compliant interface. So this means that, for example, jQuery Ajax function we used, we may not simply pass a callback here. We may pass no callbacks here, and this function will return a promise. And we can use this promise in a way we used it before. For example, here I write promise.all, and this promise will be resolved only after both requests are finished. And then we can use the data from the both requests. So, do you get any idea of promises? No, because we're not creating new object. We are using the special method all that creates promise for us. So there is no need to create a promise by ourselves. And here also, the promise is created inside this Ajax function.
Why do we need this?
Actually, on the server, on the client, in the browser, you do not often need promises. You can simply make requests and update your UI whenever requests finish. You do not always have to wait until all requests are finished. But for example, on the server, this is useful because Node.js is asynchronous by nature, so a lot of functions there are asynchronous, and therefore you should either pass callbacks to them or they will return a promise that you can use. For example, there is a function called readFile that will read the file basically, and by default it is asynchronous. So when you call readFile, it only schedules the file reading, and you cannot immediately access the data. And so, for example, if you want to read 10 files and do not fill up all your entire memory, you would read them one by one and process them one by one. And so you would either create some callback structure that will, like, after the file was read, call this function. And that function will process the file and then open up the next file. Or you could create a lot of promises and change them, and simply change them. Yeah. As we did with jQuery Ajax, you can simply pass a success key here, and it is a callback. So callback is basically a function that will be called back at some point of time. Basically, all asynchronous stuff is for scheduling.
No, I mean time scheduling.
No. So let me maybe show you, or no. A simplified version of the code you may have to write in your server application. For example, we do a read file, read file, pass a file name, for example, data.json, and provide a callback here, like function file content. And only now, inside this function, we may use this file content property, file content variable. We can, for example, write something like data equals JSON parse file content, and do something with this data, like this. But if I write here the second call to the read file, data2.json, and provide the function here, these two calls will be executed simultaneously because they are asynchronous. So these two functions will be called may be called in any order. And if you actually want to order them, you can either put this read file call inside this function. So you take the entire code you write here and put it after the first file. And this way, you basically use callbacks because this function is a callback. It's a function that is passed to read file, and it's called back after file was read.
A lot of functions in JavaScript enables parameter at the callback there.
Yes.
And once more, it doesn't have the memory problem. Yeah, this implementation, but it is asynchronously and it just.
The only problem with memory that may arise here if you do not two requests to read file at, for example, 1000. And basically, the JavaScript will try to read all these 1000 files simultaneously. And this may lead to, for example, filling up your memory.
We just have the for cycle inside the cycle.
Yeah, if inside the cycle we will call read file, it will not be executed one by one. It all be executed simultaneously. Yeah. And instead of like putting a callback function, you may try to use a promise. Suppose that read file function returns a promise. So what you can do, you can write your for cycle. For example, let us have like n files here. And here we can actually say that we create first a promise that we will use. It will be a simple promise that will be immediately completed. Like this. And since this is starting to get a little bit complicated, let me write it here in a text editor. Yeah. So let me create a file and call it promises.js. So suppose I have an array of file names. Yeah. And in this array, I will have something like 1.json, 2.json, 3.json, etc. And now, if I want to read all these files one by one, I can write the following thing. I first create like an empty promise that will do nothing, and then I write a cycle to iterate over all the file names. I call my read file function. Oh no, I do not call my read file function. I say that after this promise, the read file function should be executed with the file name and here, since I know that read file returns a promise, I can simply say return and now this call creates a new promise that will be resolved only after this file was read. And what I can do now, after this file was read, I can add another function here, call it, suppose that it accepts the data argument, actual file contents, here, and I can do something with it, for example, simply log it, like this. And now this call creates next promise, new promise 2. And this new promise will be completed only after file was read and then it was processed. And what I can do now, I can say that promise equals new promise 2. And this will basically change my promise variable. And now, if in the next iteration of the cycle, I will call promise.then, it will actually chain this function only after the first file was processed. So let's look at this code a little bit. I left here a little error with scoping, as you may remember, but let's forget about it for now and concentrate on promises.
Will you copy it or make it like deep copy or not copy? I'm saying
No, it will not copy. It will just reassign. It will not like change our initial promise. It will only change the variable promise. So think about references, yeah? Promise was referencing our initial promise here. So this was our first promise. And the variable promise was referencing our initial variable. Then I attach a callback. I create a new promise. So this is our new promise that is created here on line 8. After I do line 11, I create a third promise. And then I basically say that my promise variable should point not to my first promise, but to my third promise. And since I only change them with then, it means that after first promise was completed, the second promise function will be called. Then this function. And now if I go to the next cycle iteration, I again do the 8 line, create a new promise. Do the 11 line, create another new promise, and update my promise variable. So this is basically I changed a lot of functions to execute. And these functions will only read file after this setup will only read the file after we processed all the previous files. This is like getting back to linear code execution from asynchronous code execution. And in the end, let's actually fix the problem with scopes by rewriting this cycle via file names for each function file name. Now this code will work. If you do not remember what the problem was here, I suggest you revisit previous lectures, but let's not talk about this for now. Okay, any questions here?
Should you specify then for promise to new promise?
No, because I will specify it here on the next iteration of a cycle.
But after?
Yeah, after. Nice idea. For example, after all files were processed, I can say promise.then function console log done. And this function will be executed after all files were processed. So again, refer to this picture. So we had our initial promise. We created on line 3. Then we create a promise on line 7. Then on line 10. This was our first iteration of the cycle for file name 1.json. Now we get to the second iteration of the cycle for the 2.json file. And again create new promises on line 7 and 10. But we change them to the promise that was created previously. Not like to our initial promise, not here, but only after the previous one. And after we complete all this cycle, we again chain the final function that will call done, like this. And here should be some code for the third file.
Where you write 3, 7, 10. Why you write 3, 7, 10? No.
Because third line, 7th line, and 10th line. I just show where I have created this promise.
So we need to do this all the time. Really?
We need to do this if we want to convert asynchronous code to the synchronous code. Or I should better say, if we want to synchronize the asynchronous code. Yeah, because we're not converting it, we're just synchronizing the operations. Let's actually try to run it. And to run it, I will need, oh, not wrong browser. I'll need to Google up Node.js read file function. Yeah, so to actually call this read file function, I will need to load a library that is provided with Node.js, and we will talk about loading libraries on the next slides. I just write this magic line here, meaning that I load the file system library, and inside this file system there is a function called read file. The only problem is this function has the following signature. It accepts file name and the callback. And this function is not returning a promise. So we have to promisify this function by doing the following stuff. I return a new promise here by writing the resolve function, and I call file system.read file name, and provide a special callback, and actually the resolve should be this callback. So how it now works? In this part of code, I convert the callback style read file function. What it does, it reads the file with this file name, reads its contents, and then calls this function, the resolve, and calls this function, which is provided as a second argument, with the contents of the file. But here, we've wrapped it in a promise, so when I call resolve, the promise will be resolved, and the data that was returned by read file will be provided to the next then call we write here on the line 15. So this is how you promisify the callback style code.
Resolve makes the last, resolve is after the promise is scheduled, yeah, like it is time to make this promise, the function resolve works.
Mhm.
The function resolve and reject, and resolve is for good promise.
Yeah. And so basically, you can, again, I create a new promise, and this is just some object. And this promise basically have a function resolve. And when I call the function resolve, or actually not when I call, when read file will call this function, it will provide the data to the next function we saved in then callbacks. So this code should work. Let's try. I saved it in a file called promises.js. So now I just open up my console. It could be a terminal on Linux or Mac, or simply a command line on Windows. And I write here node and the file name promises.js, and see that all our promises returned an error, not the file contents, but an error. But the error is still an object. As you can see here, the code was not aborted because of the error. It just like says us that no such file or directory, because I actually have no these files, 1.json, 2.json, and 3.json. But the cool thing you can see here, they are returned in order. So first the first file was checked, then the second file, and then the third file. And this is due because we have written all these promises stuff, all this promises chaining stuff. Let's actually create the files. I have created 3 files, and if I now run my script again, it will print null for some reason. But as you can see, no errors, so files were read. So files were read, I should say.
Because file contents isn't
No, file contents is here.
No, I mean.
Yeah, it's null. It's not undefined, it's null. The problem here is that this callback actually is called not with the data, but first with some error code and then with the data. And because we had no errors, the first argument that read file provided to our callback is null because we had no error. And we are reading here this first argument. And we are reading null because we have no argument here. We can write something like error here. Now we have another problem because resolve only supports one function argument. So what we have to do, we have to make again this function of one argument, but here instead of directly passing the resolve to read file, we'll create another function with the proper signature, with the proper arguments, and inside this function we actually call resolve with the argument we need, like this. And finally, we see that file contents are displayed, but they are like memory buffers. It's even more efficient than a string. But to actually see them, let's convert this buffer to a string by calling a toString method. now we actually see the file contents.
The resolve function is the promise.
It-
I mean that.
It's like a callback to promise.
Okay, but the callback to promise is a new promise too. Like I mean, new promise of then. Yeah.
Yes.
New promise of then means that after the promise has its own result, yeah, we should make the function which is after.
We should call the function, yes, it is.
We should call the function file content.
So basically, when I write here resolve, when this statement is executed,
Yeah.
this function is called.
But the return from the new promise function resolve and so on will be the file contents.
File contents are actually data variable.
Yeah. Resolve means that we return this data.
Yeah, that we
from-
provide this data
Yeah.
to this function.
Okay. Yeah. Like.
Yeah. Basically, you may think about resolve as simply a way to provide the data next in the promise chain. Yeah. And since our file contents are in JSON format, we can actually convert them to the JavaScript objects by writing json.parse. We used this function before in the browser, and it's available in Node.js. So here, as you can see, not the textual string, but actual JavaScript objects were locked in the console. And I can even complicate this stuff a little bit more. I can separate this call to another variable called file object. And I, for example, may lock only the property file of this object. And now only these strings are printed. And this is how you basically process files in the JavaScript if you need it. For example, you may have a lot of files with data, and you can process it like this way. And to wrap it up, actually, Node.js provides a very nice function called fs.readFileSync. It will simply read the file in a synchronous manner without all this asynchronous stuff. It will take some time, and when this line will be completed, only then, when this line will be completed, the file contents will be populated with the actual content of the file. So I say that all this code was unnecessary that we have written because we have some synchronous function provided to us by Node.js. But not every library provides the synchronous functions. For example, when we will work with databases, the library that allows us to connect to the database is completely asynchronous. And to make it synchronous, we will have to use something like a promises. So yeah, let's make a 5-minute break here, and I'll let you think about this code a little bit of time.